Alright, on the same more practice, we're going to do parallel number 2. It says that a toaster and a heater are connected in parallel to a standard house outlet. There's an ammeter showing the current in the toaster is 1 amp and an ammeter showing the current in the heater is 6 amps. There's a voltmeter showing the potential drop across the heater, but it doesn't tell us what it is yet. Draw the schematic with both those meters and then solve the tile for the unknowns and tell me what the power in each appliance is and the total power of the circuit. So it says I've got a standard house outlet, and you guys need to know that a standard house outlet has a voltage of 120 volts. And there I'm using my generator symbol. Both the heater and the toaster will be drawn as resistors. So I can call this the toaster and the heater. It says that there's an ammeter measuring the current through the toaster. An ammeter, amigo, wants to be friends. You're actually going to have to break the circuit to insert the ammeter. So in my schematic, that's why I'm erasing. When I'm doing the lab, you actually have to unhook something and insert the meter there. So through the toaster, it's 1 amp. Through the heater, it's 6 amps. And it's also going to ask for the voltmeter showing the potential drop across the heater. And so eventually I'll know what this is. Now we do my voltmeter. Okay, I can go ahead and fill out my tile. I have 1, 2 total, and this is parallel. VIR, just like Ohm's law. Parallel starts me off with psst. And remember, whatever symbol you want to use to remind you that the R's are not regular adding. That equation. Okay, I've got 120 volts. That is my total voltage. And I know the current is 1 and 6. And I'm good to go from there. So I can solve this in multiple ways. 120 is the same all the way across. That's because up here would be 120, this bar. Down here would be 0. So bridging from here to here is 120 drop all the way across. And the current adds up, so my total current is 7. It's because 7 total came out of here, and 1 chose to go this way, while the other 6 chose to go this way. And then the total again would be 7. And I can divide down. This is 120, 20, and 17.14. And just off the top, I can check and see that it's less than either of those, and it's greater than 1. So I'm probably doing good, and you can always check by using this equation. 120 inverse plus 20 inverse inverse. It goes in my calculator just like I have it written. Parentheses 120 inverse plus 20 inverse and parentheses inverse. Don't forget that last one. And it is 17.14. So we have done it correctly. Alright, it's also asking for the power. And the equation for power is just P equals IV. That's the easiest one if you have your I and your V. So if I wanted to do P1, I'd just I1 V1. So 120 times 1. So the power here is 120 watts. Power for 2 is I'm just using I2 and V2. So I've got 6 times 120. Gives me a power of 720 watts. And for the total, for P total, I just use I total and V total. And so I have 7 and 120, and I have a total power of 840 watts. That means that the toaster is using 120 joules every second. That's how much it's sucking up. The heater is using 720 joules every second. That's how much it's sucking up. And that means that the whole thing, all together, it's going to have to provide the 120 joules per second this way and the 720 joules this way. So my power is 840.